clashes which happens will be taken care of, will be discussed, and one of the element will be moved so that it becomes a clash-free model. What am I achieving when I am talking with respect to the main topic that we are discussing today is saving time, cost, and materials. If this kind of process is not followed, traditionally what was happening earlier is you do in 2D drawings, you were not visualizing as well as what you are seeing here today. Now that means because of visualization lag, there was many clashes, so materials were getting wasted. You had to throw some materials and redo. By redo, not only time, cost, but also material was going for a task. Now what this is happening, this is actually saving time. It is giving better visuality. Now, one of the most important thing is when you read the Six Sigma programs and Lean programs, they tell how the system should be pull based and not pushed. That means you are ready and equipped when your time of work comes. So the one by one, you are ready to do the next step. Here, what this essentially is doing, one, it has created model before the execution. You are giving the model clash free before the execution. Also, before it comes, since the model is there, you can plan to buy the right material at right time. The execution engineer can view everything and get the complete visual understanding before execution. So what this essentially means, you are ready and waiting to complete the job. It's not that it comes, then you read. That's the major advantage. And it saves hell lot of time in actually reading. So this video was showing how complicated this is. If there is many disciplines working within a small space also can be planned by using volume strategy, which is the federation strategy. Well, actually what we did, we took a pump house to show independent disciplines, right? Let's look at the federated model of this pump house. Now, if you see this pump house, earlier I showed the mechanical model separately. I showed the electrical model separately. I showed the structural model separately. Now, this is a federated model. This is a live demonstration of normally what you are going to see and build. This has more or less all the disciplines put together. Now, let us kind of understand and look at various facilities. For example, this is the intake channel. This is where water flows through canal or whatever. And if I go a little further, you will see trash screen. What is a trash screen? Trash screen is something which actually stops the debris like, bigger waste. It could be some waste materials or sometimes animal waste, etc. And then you have the end wing wall. If I go in, now you can see the BT pump or the vertical turbine pump, which is pumping water from here to the main system. Let's go to that inside. Now, if you see here, this is the federated interior part of the pump house. First, I am concentrating on various civil structural facilities such as access ladder. You see the walkway. So basically, this walkway can be used to walk across and see the various facility during operation and maintenance, etc. So basically, notice that if I am walking on a completed structure, it will look exactly like this. Now, there is cased access ladder, which we can use to reach up to the crane level and during operation and maintenance or whatever the respective people will go. Over a period of time, these models get matured to become an execution model, which I'll talk in a while, and also as a safety model. So let us say I don't want everyone to come to this level other than the responsible person for maintenance of crane girder or cranes. Then you could have the access, restricted. So basically, if you see here, you can see almost all the details which is modeled as per what it is going to be executed. Now, we saw the interiors of the pump house with respect to structural details, like we saw the ladder, the walkway, the crane girder beam, etc. A very quick view of how the mechanical is getting, flushed with the overall pump house. Earlier we saw independently, right? Now based on that only the whole system has been federated. It was planned by using the volume strategy, how they will come, what would be the spacing, and referring to these only the structural persons provided their pedestals. You can see how openings are planned and these are all modeled together. So at site, when we are constructing, these openings are placed and constructed. So basically there is lot of saving of time, material and cost. Now we saw the civil structural, we saw the mechanical. Now we are looking at the electrical model. If you see, we saw the electrical model separately. Now you can see how well it is going with the overall federated model as well. If there is any clashes, one visibly you can see when we are actually doing the work continuously. However, there is a process by which we can actually do the clash check and remove the clashes at the design stage itself. So I am hoping these kind of visual samples is making your thought or the process very clear. Independent disciplines will work and then we federate them together. We verify if there is any clashes and make it a clash-free federated model. Now, this federated model, what you are seeing, has all the discipline models with it. Here you are seeing, earlier we saw the interior details. You can see that I am trying to show all the details, including the gantry girder and, basically why this is there. This is during construction and also during operation and maintenance. It can pick up things for, operation, pull them out and it can be maintained and brought in. You can see the details such as rail, also modeled. Also the support for these rails in the form of supports which is coming out from column is also modeled. Well, so the first two steps, and I'm trying to go through the life. If you observe, what I am trying to do is not randomly pick up some slides, but I'm trying to take you through the life cycle process. If you see the left side, we saw the design stage, and now I'm moving into the analysis stage. This is on the right side, if you see, if it is a typical building, as I told, the architect will first do his model. Based on his model, the structural person will do the structural model. And that model is being imported into the analytical tool such as STAD or RISA. And we do the analysis. From there, we generate the various reports. And once everything is satisfied, we generate the drawings. So basically, we don't repeat. The basic 3D model is moved into analysis tool where you don't need to remodel again. You apply your loads, do the analysis, update the model and give it back to the authoring tool. So that means I am saving time. So the overall project time gets reduced. Well, this is a description of engineering analysis through BIM, which as and when I go forward, I'll be telling. And obviously, I don't want to waste too much time on this potential values. Obviously, by deploying the BIM process, we gain huge saving in time. We save the cost. So when we say engineering studies, the main thing we do is analyze, plan and simulate. And the three disciplines which more or less is common across all kind of infrastructure projects are the structural analysis, the mechanical analysis, and the electrical analysis. As an example, for mechanical is the energy and the electrical is lighting analysis. As I understood, this is a part of civil engineering team that we are talking to today. One more before I actually move into structural analysis. When I say building information modeling, I want to clarify two things. One, the first word building is not a literal building, but it is a verb which says adding information to the model. That's why of late, instead of calling it building information model, we call information model also. We are trying to avoid building because people literally assume it is a building, not necessarily true. That is one part of it. The second one is somehow I have seen that the tendency of people to believe that BIM either is an architect's thing or a structural. No, it is an overall process. The mechanical, electrical, plumbing, structural, architect, everyone are involved at the design stage. The planning team is involved at the planning stage. The execution team is involved in the execution stage for all the disciplines. So it is a horizontal process followed or used by everyone, including the client, the vendors, etc. But since today this particular session is more to the structural engineers, I am talking about the BIM process of structural analysis. So I don't need to tell what is analysis, what is structural analysis and its potential. I am very sure and confident every one of you know. However, I would like to say how the BIM process is helping in this procedure. If you typically see how a structural design is done, we take the architectural plan or the plan and elevations. We do the structural preliminary model or the layout, which is a conceptual design. And then we do the iterative design, like depending on what is more suitable, we see the various options that is possible. And then we do the manual analysis for the same by determining the various forces coming on it, the loads coming on it, etc. And then design each members. It could be the foundation, columns, beams, etc. based on the analysis that we do and generate the drawing. This has been the traditional process. Obviously, this is correct. But can I help save time by deploying BIM is what we are looking at. And let us see whether it does. A typical workflow or a process contains obviously the three major part of it. One, the central process, the top reference information, and the bottom information exchange. When I am doing structural analysis, the first reference is the data that I get by various tests that we do, such as the soil data, the wind loads, the seismic loads and snow loads that we take as an input. And the information exchange or the input for me to work on is the architectural model on a building kind of structure, or it could be a mechanical layout or the mechanical model if required on various process oriented models. So as a structural engineer, I got my data and I got my input in the form of model. What do I do? By referring to the architectural model, let's say, I generate my structural layout, and by generating that parallelly, basically I'm actually creating a structural design model or the 3D model, pardon. So basically if you see, this is how it will look. What I do next is export this model which I have done. For example, if I am doing in a tool such as Revit, I export it to the analysis tool such as the STAD or RESA or ETAB, etc. to analyze the structural model. Here we apply various loads which is applicable. It could be dead loads, point loads, UVL, UDL, whatever. And you generate your bending moment diagrams, displacement diagrams, whatever, and come up with the analysis and decide the final structural model. Once this is done, basically I export the analyzed model back to the main authoring tool such as Revit. So basically what happened, this is the most important thing. I did my design 3D model using, for example, an authoring tool such as Revit. It was then moved into the analysis tools such as TAD or RISA or ETAB or whatever. There we put loads, we did the analysis, updated the model and brought it back to tools such as Revit or whatever design authoring tool is. And from there we generated the drawings. So basically there is no duplicacy. That is the most important thing. Earlier what happened, even though we started doing 3D model, we were doing in silos. So the author tool and the analysis model were two different. So there was many a times mismatch, and then the structural engineer, if he is telling, "Array, I had given a beam here, you don't have that beam in your model. You missed it." So this kind of thing was happening, but by using one model, that means there is only one truth in the project. That is why these kind of problems are taken care. And it takes care of errors, it takes care of wastages, it takes care of total time, and obviously cost. Now, is that it? No, what we did, if I am to explain from first step, we planned the concept, we did independent discipline models, we brought them together, we did the analysis. That analysis model became the design rich model. Once my model is design rich, that means I have all the data in my model. I can generate drawings. Earlier, people used to draw, but in BIM process, you don't draw. But what you essentially do is generate drawings from the 3D model. This video, if you see, you can see that the drawings such as a plan view, section view, elevations are coming out from 3D model automatically. In BIM process, all the drawings should get generated automatically from the model. Of course, there will be some cleaning or some zooming of some portion, etc. But mostly 90% or even 95% of the drawing is automatically coming from the model. So what this essentially does is, of course, I keep telling people, and I have shown in many of my teachings and presentations to people, that when we were in traditional method, when we were having 2D drawings, many errors were happening, especially the typo errors. For example, my typing of elevation or my typing of coordinates was going wrong because of typo. Instead of 230, suppose I type 320, you can assume what kind of blunder it could happen on site. But then for typing, it is just a simple typing, right? But here, with this process, what is happening, drawing is getting automatically generated. Those values are automatically coming, and hence such errors are taken care. I want to show some samples from the project you are seeing at a metro station. If you see, this is the drawing and that's the model. I'm trying to show that how drawings are getting generated right from the model. Various views showing the drawings and the model, right? Just to tell that it is not just few views like plan or whatever, the overall everything, including reinforcement, could come from the model, right? Now, if I take the life cycle, I started with conceptual, I went to the design. After design, I generated the drawings. What is next? I go to construction, right? So let's look how BIM is helping at the construction stage. I can do my logistics. If you see here, at the beginning of the project itself, I can put various details like what you are seeing in here in screen, where I can play or digitally look around things to plan my entire layout, how my trucks will go, where my gates will be. You remember our project sites are crumbled. There is no enough space. I have to plan how much depth I have to go. I have to see how I bring out the materials. This, when I'm actually doing inside, if I land in trouble, it's wasting time and stuff like that. But what we are doing is we are digitally rehearsing. This is what Haima also was telling earlier. Basically, if you see here, I did a site logistic plan. I know up to what depth I have to go. I am seeing how people will come there, what is his access, what are the supports I am giving because I am going to that depth, is what is being planned, viewed, and once I am satisfied, I can actually do it inside. It is not just that. Remember, there should be my site office, and that should be convenient enough for the site team to come and go. So all this logistics, every detail can be planned, viewed, and seen. So basically, what I am doing here is I am starting from scratch. In fact, we can digitally build an entire structure before it is actually physically built. If you see here, not just that, we can we can work with various teams and bring all the facilities together. Here you can see how the form work for a concreting goes through. Let us say we have a new engineer who is going to execute. He has not used such earlier. You can show to him and then obviously go ahead and construct the same, right? All these are Revit models, and this has been put together and demonstrated well in advance before you actually construct. Now, at this stage, before I go to the next video, what I am trying to do here is two, three things. One, digitally build it before actually construction. The second thing is, when we say 4D, we know what is 3D. 3D is what? Length, width, and height. The fourth dimension is when I am adding schedule or time. So if you go back to one of the slide I showed the Gantt charts and the model. What actually is happening, the project planning team is coming into force here. The execution team is coming into BIM process here. What the planning team is doing, he could do within the 4D tool which is available in the market, or he could use his planning tool. He plans the building, like for example, which elements, like when the foundation should happen, when the columns should get erected, when the various slabs should get erected, what is the predecessor and what is the post-decessor activity. He plans everything and he connects it to the model. And basically, through colors, I can see what is planned and what is happening. That is the fourth dimension. So based on the time, if I can view such model, for example, here we are looking at how a steel girder is getting erected. Basically, before actually it gets done, what will happen? The advantage is you know how you are going to work. So these equipments, what you are seeing is more or less the real equipments which is available in the market. Some of these equipments are actually the model provided to us by the vendors who are actually manufacturing these. So that means to say these are live sizes. We could even see how, for example, if you see in the concrete, the anchors were already put. When I'm erecting steel, there is a plate in it which has holes and then they get bolted together. The details are clearly shown. So basically by looking at this video, the person who is going to cast the concrete knows that at this position there should be anchors. So that means he is well prepared. So he looks at the drawing, he knows why those anchors are coming. And by chance, if there is a possibility of him missing, it is taken care actually. Well, what we saw in the last 2 or 3 videos is basically the structural items. The questions could come whether it is only for structural items. Well, no, anything and everything will get modeled and rehearsed if required as per the project requirements. In the next video, we will look at the next discipline. Here, in this substation, for example, I want to show how an equipment is getting erected. You could plan the logistics of how these are brought, from where you will lift, and there could be some temporary slabs erected on some projects, or there could be a projected slab where you will keep, and from where it gets. For example, it was brought in a vehicle, lifted up and placed on a slab. So these kind of construction analysis or rehearsal you can do well in advance. Here you are seeing this has been planned. If there is any issue, for example, there is no space for this truck to stand here, etc., is visible and you can plan accordingly. Once placed there, you can see how using the inside monorails or girders, they can be lifted and placed. Well, one of the most important thing according to me is when we say construction, unfortunately or fortunately, even after so much of awareness, there are untoward incidents happening in sites. That means safety issues. So mostly as a BIM person, I would like to highlight that utilize BIM for safety. What does BIM for safety does is I am trying to cover the process. If you see, we saw the design. We saw that I can help in execution. Also, I am showing how you can work safely. Let us say a person here, as you notice, is standing in the wrong position. Here, he is standing in a place where he could get hit by moving objects or some materials falling from height, etc. Now, here this crane is lifting the reinforcement for pile, but he is standing in its way, so he will get hit. So what essentially I could do in my 3D model is notice such things and also highlight that as restricted area. Once it is there in the model, when you are viewing the model, you know that there is restriction area, and inside also you mark in such a way that people don't unnecessarily go. So that means I am saving lives. We are taking care of safety as well through the model. Now, as I told, we are there right from beginning to the execution part of it. At various stages, we need various equipments to view the model. The technologies are not only looking at them through computers or through mobile phones or anything, but also it has moved into the VR, that is the virtual reality, augmented reality, and merged reality. Virtual reality is, you know, you wear a headgear and you see 1:1. You actually get yourself immersed in the digital environment. In augmented reality, you see the real world with digital information overlay. And in merged reality, you merge the real and virtual worlds together. Now, all this right from beginning, I told we are working as a process right from conceptual to the end. Now, all these, if I'm working in silos, then it doesn't work. We work in what is called as common data environment, for which it works normally on cloud. Mostly all of us know what is cloud. If not, I would like to tell you all have seen cloud, like for example, your Google Drive is a cloud. Most of these photos that you have on Google is also placed on the cloud. Most of the bankings nowadays is on cloud. That's why you can access through various apps such as Paytm, Google Pay, etc. So basically, the advantage of cloud is now, for example, can I enter into your Google Drive unless you give me permission? No. So basically, a cloud computing is way it is independent. you bring various apps, various people into one platform. You give them access by any kind of hardware, such as if you see your desktop, server, laptop, mobile phones, tablets, but again based on your role and responsibility. The common data environment, what we call, is the cloud-based system, which does the same. So traditionally, what was happening, if you see on the left side, each one was talking to the other independently. Let us say I am an engineer, I did my drawing, I am giving to the contractor one drawing. And the contractor is taking that and giving to subcontractor. Subcontractor is passing it to the vendor. You know, on the left side, if you see, there were so many crisscrosses. And because of so many crisscrosses, let us say the engineer released revision 4. In engineering, even today, there are revisions, various reasons. I don't necessarily tell revision is due to error, but various reasons. Like, for example, many of power projects, what would happen, some of the vendors, especially who are going to come at the later stage of the project, for them, for that information, what equipment is there, we don't know. So what footing we have to put, we don't know. So what we would do is we make secondary foundations and leave it and put a hold around it and later on make the next revision. So revisions are inevitable. But then the other problem was when I make a new revision, because there are so many crisscrosses, my latest drawing was not going to be there with the site team. The site team used to call and tell with the issue, and then engineer used to tell you, Are Baba, you are looking at revision 4, I have already released revision 5. That's because there was no one source of truth. Now look at the right side. We have a central server which is on cloud, which is having all the project information. All of us are accessing information there based on our roles. So if I am a design engineer, I have my own rights. If I'm execution engineer, I have my own views and stuff like that. So basically, I have data in one center point and all of us are accessing it. So this is a definition for CDE. Anyway, keeping a time viewpoint, I don't want to get too much into it, but basically it is again being run on the ISO 19650 process, and right from brief, that is starting right through operation and maintenance of the life cycle, you should ideally have your data only in one place, and that is common data environment. This is again based on the main references of ISO 19651, ISO 19652, and then BS 1192 2000A2 and PAS 1192. These are the main references for working on common data environment. Basically, the concept of CDE is very simple. It brings the people, data, and the process together. It is a cloud-based system which is working on the process that I told. It goes from work in progress to the shared. As I told, the work in progress is when each disciplines are working independently. The shared is a federated model. And from federated, the published, that is, I'm generating drawing and issuing drawings and model, which is being used, which is in published. And at the end of the life cycle, it goes into the archive. The whole process is on the cloud-based CDE. Now, accessing these is role and responsibility based. I'll try to explain in a very simple way with some kind of example. One of the things what happens on a given project is when we start the project, most people don't know what is his role and responsibility. I only know I'm a structural engineer. I only know this, but what more? That's the thing we will see. Normally, a team lead or the project director or the project manager or the engineering manager will define the role and responsibilities. I'm a BIM manager, I'm an architect, I'm a contractor, I'm a safety engineer and stuff like that. Now, once I know, for example, I create a project space where I can store all the data and then I give access to the data based on your role. So basically what will happen, if you see here, an architect is asking the admin to give access to the project folder. Now what is the admin telling? Since you are the architect of the project, I am going to give full folder control to you for the architectural folder. That means For the architectural folder, the lead architect will have all the access controls such as the view, download, upload, edit and delete. Now the architect is happy. However, he is trying to tell he may have a modeler with him who has to download, upload and edit, but he is afraid that he may delete because he is a junior or a young guy. So what admin tells, I can do such that I can give just a view, download, upload and edit and no need to give him delete access. Now, the next point, the architect may be getting a vendor who is supplying, let us say, window types, window panels or wall panels and stuff like that. So he is telling I have few vendors who are going to give me various materials such as electrical fixtures, etc. So I need him to download my model, plan his sizes accordingly and give. So basically what he is doing here, he don't want him to edit, right? So he's going to give him only view, download and upload access. Similarly, there could be people who are just going to upload their drawings. So for them, it will be upload only access. Or I could give view and download only access. Or even view only access. So basically when I'm in common data environment, mostly people are afraid of their data. So this is trying to tell that it is secured and role and responsibility based permission which the admin can decide. So basically you could give view only, view and download, upload only, view, download, upload, view, download, upload, edit and view, download, upload, edit and delete. Raise your hand if you have. Actually, I will just run this video once again. Once we have the common data, once the model is done, I can do all my work here. So basically, I am just taking one part of it, that is reviews, that takes forever to complete. You know, once your team don't have the right tools to capture feedback, or they can see every change to the shared models. So everyone in the team is doing a ton of rework again and again. Yeah, we got tired of that too. So we switched to BIM review tools on common data environment. Now the team can review and mark up design data on any device from any location. Switch models or 2D sheets straight from the browser and even assign and manage issues all in one place. The best part is I can get everyone involved with adoption of design review in common data environment, including clients and subcontractors. Even if they don't have the required skill set, as it is very easy to train and adapt. That's pretty cool, isn't it? Let's see how adopting the design over the common data environment can improve your next design review. Basically what this small animation video was trying to show that is over my tool, that is common data environment, I can mark my drawings and process it and send it across to each individual. Earlier what was happening, for example, let us say I am working in the site and I had an issue. I had to take the drawing and put my comments on a mail and send it with some snapshots and stuff like that. And it was happening one-on-one, and also to refer, I had to refer to 3-4 drawings. However, in common data environment, I can mark up then and there. I can earmark to whom, and all these all actually gets how is, like if you see here, in the model I am marking and I am telling what is my mark. And if you see the yellow pointer, actually I want him to concentrate there. Various options are there which I am trying to mark. I can put my comments and this is going to the particular individual. I am writing what is the issues and I am sending it across to that particular person to whom I am sending so that he can comment back to me. So for doing such reviews, it could be one step, that is I am modeling and I can give to my lead engineer. That is a one step. Or it could be where two steps, where I'm giving to architect and then to project manager. So basically two people are reviewing and giving their comments. Similarly, it could be a 3-step process, 4-step process, 5-step process. All these are inbuilt or developed within the CDE environment. This could be even group. That means at a given point of time, I can give to 3 people to review and then finally to the team lead. So basically, these kind of process can be set up and reviews can be done quickly and all are being documented and saved. So basically, we are crashing time. We are removing the uh, coordination or collaboration issues that projects were facing.